Sabri? Join பண்ணிட்டீங்களா?
பண்ணிட்டேன். வேற 9:30க்கு சாரோட மீட்டிங் இருந்தது அதான்.
Sure. Okay, today we are trying to implement this particular block. Okay, whatever things available in yellow we are trying to implement. Whatever things in the blue that we are going to do in the next class, and we are going to combine with this. Okay, so binary source. So last class you took a signal, you sample, quantized, encoded, and you converted as a binary source. Okay, binary information. Now that particular information I have to exchange with my friend. Okay, I want transfer. So I am trying to do a modulation and I am transmitting. When I try to do the modulation and I try to transmit, I am facing some set of problem. I am facing intra-symbol interference. Okay, one symbol is overlapping with other symbols. Okay, so one symbol, other symbols are giving interference to this. Okay, so at the receiver end we are not able to detect the signal correctly. Okay, we want to overcome the particular problem. For the purpose we are incorporating pulse shaping. Okay, so first when you are started, we introduced one shot communication system. What is the meaning of one shot communication system? Only one symbol is exchanged between transmitter and receiver. At the time we don't have any problem because only one symbol, infinite bandwidth, no trouble. But now what is my problem? When I try to go for a real-time communication system, this is not feasible. I have to transmit sequence of information. Okay, now when I go for a large amount of bits, okay, and I'm trying to limit myself to a limited bandwidth because the infinite bandwidth is not possible. The FC is allocated, each application has to go with a specific frequency band, so we are trying to limit ourselves to a specific bandwidth. Okay, but whatever we try to create is a rectangular pulse kind of thing. Okay, so we studied PAM, binary PAM, and MRA PAM, PWM, and we studied some line coding techniques. All these things we used to convert zeros and ones to some electrically varying representation. The reason, whatever channel we have is a continuous channel, we can't give zeros and ones as such to the channel. So once again, binary zeros and ones we are converting a time varying representation, either with a line coding technique or with some more baseband modulation thing. Okay, so that is the thing happened here. That is the thing simply I drawn as a mapping here. Okay, so this particular mapping do some representation. So here I have 0. So 0 I'll try to express with a pulse something like this. Okay, starting with I, falling down and keeping low. Okay, and if it's 1, I will go with the reverse. Okay, so this is one of the line coding technique. It's a Monster coding technique, or you can go for NRZ, or you can go for a normal plus and minus representation. 0 you can map to a rectangular pulse. Okay, 0 to TB, 0 TB. TB is a pulse duration and amplitude is going to be A. Okay, the same thing inverted for 1, that is the same duration 0 to TB, but the amplitude is going to be minus A. This one will call as an antipodal signal. This thing we study. Okay, so such a mapping only I am trying to do it here. Okay, so binary information, the corresponding mapping is drawn here. Okay, so anything you can use it. You can go for a PAM or you can go for a PPM. Okay, so whatever you are comfortable, you try to use that, you convert to this particular time varying representation. Okay, now we already studied if you are using a rectangular pulse. Okay, if you are time domain you are using rectangular pulse, if you are finding the corresponding frequency domain, we form a sync pulse. Okay, the sync pulses look something like this. Okay, so it's keep on moving. Okay, because the time we consider signal is going to be limited 0 to TB. Okay, so what will happen? The frequency domain, it is going to be unlimited, but our constraint, we have to work only with a specific bandwidth. Okay, so what we are trying to do, we are trying to change from the rectangular representation to some small variation that is going to have a limited bandwidth. Okay, that thing only we'll call as a pulse shaping. Okay, so what will happen if I use the rectangle pulse as such? So this is my first information. So for this I will get one rectangular pulse, so one sync pulse in the frequency domain. Okay, it's keep on continuing, and for this one I will have one sync pulse. Okay, the frequency domain, not in time domain. The first one is the time domain, whatever I'm drawing now, the red color is a frequency domain. Then I will go for this particular signal. What will happen here? The negative, still I have some signal. So what will happen here? The first signal is overlapping with the second signal, and third signal also overlapping with the second symbol. This one we'll call as a inter symbol interference. Okay, so this arised because of this rectangular shape. Okay, so I'll try to modify that to a different representation. Okay, some people tried with a triangular representation. Okay, some people tried with a crossway representation. Okay, now some people found it will be more beneficiary if you are going with a raised cosine filter. Okay, so it's a something like a sync. Okay, the sync pulse only, they are going to stretching. Okay, the reason for stretching, I want bring all my energy within the specific time duration. Okay, this is my sync. Okay, here I have maximum energy, but here also I will have some amount of energy. Okay, so what I will do now, in the sync I will try to raise this. Okay, when I try to raise this one, what will happen? This energy also I will try to bring it here. That is the way the raised cosine filter is created. Okay, in the book you can find the equation. Based on the equation, that is sync is multiplied with some factor that is going to provide you the raised cosine filter. So to avoid ISI, I am introducing pulse shaping. Okay, this particular pulse I am converting to this particular format. Okay, now what will happen when I consider infinite number of information sequence or large amount of information sequence? What will happen? Everything is going to get added. So if I consider here, what will happen? From year to year, the first symbol duration, I have this pulse. Second symbol, this one. Okay, now because of the second pulse is overlapping with the first pulse, the effect of this and effect of the second one and effect of third one are getting added. Okay, so addition of everything is going to give you the pulse, so the transmitted signal look in this format. Okay, this one for any specific pulse, and this one for entire information whatever given here. Okay, that is something around 10 bits I took. For the 10 bits, when I put everything together, okay, all the effect, first symbol effect, second symbol effect, third symbol effect, I will get something like this. Okay, so this one is a filter I used that is going to create a square rectangular representation to a band limited signal. Okay, this is also having some bandwidth. Okay, but the energy I am trying to maximize within my desired duration, and after the particular symbol duration it is going to be very minimum. Okay, that is the reason we are choosing a raised cosine filter. Okay, so first you try to take a binary signal, plot mapping, do the mapping and plot this one. Then for each symbol you try to plot the raised cosine effect separately. Then you add everything, it is going to look like this. Okay, don't take more symbols. For understanding purpose, try to go with 10 bits, not more than that. Okay, so last experiment we are trying to incorporate more than 10,000 bits. At the time we look other things. At present you take only 10 bits, do the mapping, do the pulse shaping. Okay, so this one is this one at the transmitter side. Okay, I made my signal to be band limited. The advantage of this technique, it is going to limit our signal to the, it is going to comply with the FCC. For this particular application, only this particular bandwidth is allocated. So I decided to make my signal available within the band limit. Okay. So here we are facing some set of problem. Okay. So because of this effect, there will be some amount of symbol rate is reducing. Okay. That we studied in the theory part. At present, I don't want to introduce here. Okay. Anyhow, we are doing the pulse shaping. The what it look like, that we are analyzing with the help of a eye diagram. Okay, so here the eye diagram is plotted here. Okay, so what is the eye diagram? Why we are giving importance? The eye diagram, we are interested to understand which particular time sample, if you sample the signal at the receiver side, we will get better performance. Okay, to understand that we are using the eye diagram. Okay, so this can be done in a CRO. So whatever incoming signal you give on probe, and there will be some two vertical plates. Okay, in that you are going to apply the swiping signal. Based on that, instead of continuously plotting the signal, it is going to plot one on another. Okay, that is going to give a eye diagram effect. Okay, so there is a one animation that is given in the website. I will show you. Yeah, are you able to see this diagram, eye diagram? So assume there is a signal. Okay, so this signal you are transmitting. Okay, now what will happen? This is the first part that they drawn here. Okay, second symbol, instead of continue from this particular location, they are overlapping from the starting. Okay, so that blue color is once again drawn from this particular point. Next symbol. Okay, so this one is plotted, next this one is plotted, so everything, okay, they're plotting one over another. This can be achieved in the CRO by giving a swap signal to the particular magnetic, okay, the particular location. Okay, and that we are not able to express, but here we are using a for loop. With the help of for loop, I am plotting signal on the same location, that is going to give this kind of effect. Okay, so this one we are going to see. Okay, so here, so one signal, this is first thing I plotted, next I plotted from here to here, then from here to here. So like that I plotted multiple things, I got an eye diagram. Okay, so here this is the eye opening. Okay, this is zero crossing, this one is a peak distortion. Okay, so wherever I is open a large amount, that particular time we are interested to sample the signal, that is going to avoid error. Okay, at present we are tapping from the transmitter side, that is before transmitting I am tapping, there is no effect, but the real time the received signal they will try to analyze it, that is after a channel they will put this particular block, there will be too much of distortion. Okay, at present just for understanding purpose I put this particular block here. Okay, whatever you are transmitting, that alone you are analyzing. Okay, so this is the second part. Third one, you transmitted something, we have to receive and demodulate and detect. Okay, so here there are two demodulators available, correlation type demodulator and matched filter demodulate, whichever you're comfortable you can do it. Okay, so here important thing, how you are going to design the filter. Okay, so if you are going for a correlation type demodulator, just the base signal what is available, what is the receipt signal available, so you do the correlation. Okay, so take the receipt signal R of t. Okay, at present and the present state, now the transmitted signal equal to received signal, that is a condition we are going to put. There is no channel, there is no noise, so take the signal and take the base signal, that is, you know that for PAM the base signal is going to, the base signal is going to look like 0 to TB 1 by root TB. Okay, so you correlate with this signal. Okay, so correlation function is available. X correlation is available in Python. By using that, you can do the demodulation. Okay, once you do the demodulation, you will get a result. Then you use a threshold. Okay, above 0, you will map it for 0. Below 0, you map it for 1. So that is the way we are doing the experiment. Okay, today objective, try to design pulse shaping demodulator and observe what is happening at the eye diagram. Okay, all the codes are available, just go through, okay, and implement this diagram. Okay, if you have any doubt, you can raise.
Sir, only finite number of bits is enough, no, sir?
Yeah, I told at present finite number of bits.
Okay, sir.
And the TB, you have to choose yourself. Okay, I don't want to specify the value. Okay, the bit duration. Okay, that you have to decide whether you want have the repetition of 8 or you want repetition of 10, whether you want repetition of 20. That you can choose. Based on that, your sync pulse shape will change. That's all. Any other question?
No, sir.
No. Okay, if you have any questions, stay. Others you can leave.
Sir, for the second batch students, we don't have the link to submit the first experiment, sir.
Today Sabri sir will create. Don't worry.
Okay, sir. Okay.
Second batch students.
Sir.
Second batch students are all here, no? Right? See, I
Yes,
was
sir.
quite busy in the first year subjects and other second year exams. It will be done. Don't worry. Okay, I'll be doing it.
Okay, sir.
Okay, don't worry about those things. Second batch, entire second batch. I'm just telling. From today, it will be there. Okay, don't worry. Okay.
Okay, Dagana, we'll wind up. Okay,
Thank you,
sorry.
sir.
Teams I'll just call you.
Okay, okay.